Welcome to Haxby Shed. Some of my viewers will know that I've been considering buying a TIG welder. Never done any TIG before, and it was going to be now or never. And guess what? It's arrived. So one TIG welder and one trolley. And you can see perhaps that I've got the gas bottle there at the back near the sandblaster cabinet. So we'll get this out and find out what we've got, and I'll explain why I chose this particular welder. Washer has just escaped. Never mind. Oh, there they are, open in the bag. Book. Packing list. Stuff down the side. Oh yes. 24 kilos, I think. There we are. Oh yes. Pipes, torch, regulator, gloves, stick welding kit, etc. I suppose the next step is to build the trolley. Otherwise I'll have nowhere to put it, will I? These are all the goodies, including the foot pedal. This is sold as trolley heavy duty, and looking at these wheels, it does look pretty good. I think if you buy it separately, it's about £100. More washers floating around. Oh, that's quite heavy. Chain. No instructions found yet. The trolley assembly instructions are online. Last piece. I don't have any connection with this company, by the way. I had to pay what you would have to pay. I did say that I had a video channel, but they didn't blink. So obviously I'm not big enough yet to get anything off. For that reason anyway. Well, the instructions say the first thing to do is to put this upright onto this base, and I found that the holes line up very easily. There's no difficulty in putting this together. And then the second thing to do is to put the wheels on. Everything was a nice tight fit, and it does seem pretty sturdy. So the front wheels go on with M8 screws, washers and spring washers, and they were all there. On this side they're captive welded nuts, so it makes it easy to fit. There we are. Ah, right. Okay. Washer and split pin first. I'm making a few improvements to this rear wheel arrangement. I've put 16mm washers on here rather than the 20s that were provided, because the 20s are really quite sloppy. The other thing is, this shaft is quite sloppy in here. So I've just taken some 20mm white conduit and made up a sleeve here, and that will act as a bush. And it fits quite nicely. There we go. Now I'm not going to go racing with it, am I? But it just makes the whole thing much tighter. I've got these uprights on the third attempt. I got them right. So they actually angle up towards the front. And also the open side needs to be on the outside of this tray. I've tried all the other permutations and it doesn't work very well. So now it's time to put the tray on. And the tray goes on with the open side up, but this way round. There we are. It's all together now. Everything was right. The only difficulty was me not reading instructions properly. I think I had one of these off about 3 times before I got it right. You have to put your own plug on, but they have supplied one for me. Right, here goes. Now to begin with, my connection is going to be actually from a 13 amp socket. I'll rig up a 16 amp outlet soon enough, but as long as I'm keeping the welding current down below about 170 amps TIG or 125 amps stick, this will be fine. It's just really an adapter, isn't it? And it's got a 30 milliamp trip in line there. We don't really need that in here because it's already protected by an RCD in here, but it's not going to hurt anything, and I bought it like this and we'll try it as it is. There's a double pole switch on the back which should bring it on. And we're getting close to the point where I need to read the manual now and figure out how to work this thing. Regulator, flow meter. I'll leave it at that for now. Give me time to read the instruction manual. I don't want to rush into it. I'll look at it again tomorrow morning. Well, it's now the next morning, and I spent yesterday evening going through the instruction manual. As I said at the beginning, I've never TIG welded before. It's a totally new experience for me, so I'm an absolute beginner. Of course, I've done stick welding, but never TIG. And I want to tell you why I chose this particular welder. Now, you might think, well, how can this guy have a valid opinion if he's never done any TIG welding? Well, the reasons were, in a way, quite general. As you can expect, I looked at the specs of many welders, I put them all on a spreadsheet, and I began to pick out the various differences. Now, the good TIG welders have very similar functions, but this particular welder has got a duty cycle of 60% on its full current setting. Now, many of the welders have a duty cycle even as low as 20%. Now, I don't expect to be welding at full current for long periods of time, but it's a measure of quality. I think it's a measure of the design, so I was quite attracted to that. The second thing is that the support for this welder is extremely good. It's a UK based company. I did a couple of support tests myself by sending them queries. I got very good answers back very quickly.
So that was another factor. It has a return to base 3-year warranty where they will come and collect it from you. You don't have to pay. And that is something very attractive. Because I've bought big items like this before where it's an overseas welder. The person who's selling it in the UK is really just sticking a label on it and that's all. And you can't get proper support. They don't know what's in the welder, in this case, whatever the product. They don't know what's in the product. And you just left high and dry, you spent all that money. So to me, support was a very big factor. Another big factor, believe it or not, was the fan. This welder switched on, you don't hear the fan. And the fan will not come on until you start welding. And then it will go off about 45 seconds later for TIG welding. For stick welding, the fan will come on straight away. Now, if you're working in a noisy industrial environment, who cares if the fan's running or not? But if you're trying to work in a quiet workshop and video, the fan can be a total stressor. And so that was quite attractive to me, to find one where the fan only ran when you're welding, at least on TIG anyway. And the final thing that attracted me was power factor correction. Now I have a bit of a query on that now, but I looked at some welders with a power factor of about 0.7. Well, that's pretty inefficient, to be honest. I don't know whether this can get to a power factor of 1 or even 0.9. I just don't know. But the idea of the power factor correction appealed to me. And it'll weld 210 amps on TIG on a 16 amp supply feed. Now I had a bit of a surprise last night because I thought it would also weld stick on a 16 amp supply feed up to its maximum, which is 160 amps for stick. But in the book it says 23 amps. Well, that's okay, I've got plenty of power down here. That's not a problem at all. But it was a bit of a surprise, and I've actually sent a support query to them, asking them what is the maximum current stick welding I can do on a 16 amp supply. Because on their website they don't say that. They say it will weld to its capacity on a 16 amp supply. So I need to query that. Anyway, let's have a quick look at some of the buttons. I'm not going to run through it in any detail because I can't. I don't have that depth of understanding yet. And there are much better videos around which would take you through all the buttons. But I'll just point to a few at least. When I was first looking at welders, I didn't like the idea of a digital welder. I liked the one with the knobs on, and I'd have more feel for what I was doing, I thought. But actually, there's a limit to how many knobs you can have, and there are so many parameters you can tune, you'd just have a massive panel full of knobs, and it wouldn't work. So digital had to be the way to go for that reason. This chart here is quite useful at decoding which parameter you're actually changing. So as you step through the sequence of parameters, you can see how that red light is moving over that waveform here in this area. And so with a bit of care, it's fairly easy to select the parameter that you're changing. So that's now set to welding amps. And if I twist this knob here, you'll see on this screen here that incrementally I'm changing the welding amps. So that's relatively easy to do. For TIG, there's an AC easy setup and a DC easy setup. And if we were to work around all of these panels, they're fairly intuitive. It also stores up to 9 programs, and it comes pre-programmed, and there's a chart which tells you what each of the programs are. And for me, I'm probably going to start with a bit of stick welding because that's what I understand. And so if I was to move that to 9, that's the pre-stored stick welding program, about 90 amps, something like that. And that's what I'm going to try. And when we move the program to 9, the fan will come on because it always runs with stick welding. So let's do that now. So we're just stepping through 7, 8, 9. I've just tried out my first bit of stick welding with this new welder. It's the first time I've ever done DC welding. And I don't know whether it's because it was DC or because of this new welder. It was just so much easier than the old AC transformer welder. I just welded 2 bits of plate together. This side was my last run as I was getting used to it. I don't know if you'll be able to see that. But it was relatively simple to do compared to using my old welder. And I've bought one of these masks which have the reactive screen, and you can see through as clear as anything until you strike the arc and then it darkens. And at first I was very nervous of using it. In fact, to begin with, I was actually using this old thing, this old shield, and I just couldn't get used to the idea of not having this in my hand. Anyway, after a couple of goes, I got my confidence and I was okay with it. Just to jump forward 24 hours at this point, I've had a reply from Artec, and they say, yes, if you're stick welding at 160 amps, then potentially you'll need a 23 amp supply. But in most cases, people can operate these welders on stick quite happily with a 16 amp supply if they're not winding it up too much. And with TIG, which has got less demanding power supply requirements, quite often people run these welders on a 13 amp plug supply, which is what I'm doing actually right now. But I have this test device which will show me voltage, current, power, and I think power factor actually. And I'm going to do some test welds with this in and just see what current it draws at various current levels. It's going to be a bit difficult to video. I'm going to have to put my camera facing this actually whilst I work the arc. And I'll test it, I think, at 85, 95, 105 and 115 amps. And we should be able to project what current this is going to draw on stick welding right up to 160 amps. And then I can decide whether to install a 16 amp rated supply or actually having to go up to a 32 amp plug, as it works here in the UK anyway, and probably with a 25 amp breaker. I'll just make that decision based on this data. Now I'll weld at the 4 different currents that I mentioned. I'll take those readings and then we can put them on a graph and project what the maximum current load will be of this welder at 160 amps. So I'm about to set this to 85 amps and do the first weld. Now we'll try 115 amps. I took the readings and I've drawn the graph. Here it is. My readings would give a progression which leads to here, this lower line, but I've also marked on 23 amps supply current at 160 amps welding current, which is what it says in the specification. And I think you can see the two are very close there. But I've also marked on 13 amps supply current, which would give a welding current of about 100 amps, and 16 amps supply current, which corresponds to about a bit over 110, 112 amps welding current. Now we get into the science of wire link fuses and miniature circuit breakers, because a 13 amp wire link fuse, which we have in our plugs here in the UK, will carry 20 amps all day. And also a 16 amp miniature circuit breaker will carry about 1.5 times its current for about 10 minutes if it's a B rated breaker, so that's a quicker blow breaker. And so it's not a problem if there's an excursion beyond 13 and 16 amps. These
miniature circuit breakers and fuses are not current limiting devices, they're protection devices, and they're there to protect the cable. Now the cable that goes to the welder, the power cable to the welder, will carry about 25 amps, that's its rating. So I can see why Artec have said a 16 amp MCB is sufficient. Didn't want that to happen. In case you've not seen one, this is a UK domestic plug with the 3 rectangular pins, and inside it has a wire link cartridge fuse, so 3 amps in this case. And then here we've got a miniature circuit breaker that we would find in the consumer unit, and in this case it's a B16. So 16 amps, and the B denotes how quickly it would trip with an overcurrent. So I believe you can get B, C and D. B will trip the soonest with an overcurrent, C and D more slowly. And on my compressor I've got a C16 because the initial overcurrent with the motor startup would trip out a B, but the C is okay. So whilst we're talking about measurements, let me say that the power factor reading that I took whilst I was welding was 0.97, which I think is pretty good, and indicates, I think, the power factor correction in the welder works pretty well, given that some other welders were showing a power factor of 0.7 on their spec sheets. I've just set up my old transformer welder because I want to measure what current this draws at various arc welding settings. This will be about 90 amps. This is power factor at 90 amps. Welding at 110 amps. So I've drawn the results I got from testing the old welder on this graph. 90 amps welding current required 18 amps supply current, and 110 amps welding current required 23 amps of supply current, and the power factor was 0.5. Now in 43 years I've only had the 13 amp fuse in the plug blow once, and that was probably when I was welding 115 amps, something like that. So it just goes to show just how much current those little 13 amp cartridge fuses in the plugs will actually take on a pretty long-term basis. It's quite an education to do this. It just shows how much of a difference that power factor makes. It really is the power efficiency of the device. If you're not familiar with power factor, let me just briefly say that useful power comes when the voltage and the current drawn are both in phase with each other. And if they're fully in phase, the power factor is 1. And the power available is simply the voltage times the current, like with DC. But if the current drawn is out of phase with the voltage supplied, then there's a reduction in efficiency according to a cosine function. And if the load is very capacitive, the current waveform will lead the voltage waveform applied, and the reverse is true with an inductive load. So my welder, my old orange transformer welder, is a highly inductive load. So in that case, the current drawn lags behind the voltage supplied waveform because of the time it takes to build up a magnetic field around the coil. I'm surprised it was as bad as 0.5, but I knew it would be bad because it's just a whacking great transformer. And the other thing to say is the current scale, the output current scale,
is only very approximate. So when I said 90 amps, there or thereabouts. But you can clearly see the difference in the performance of the two welders anyway. I don't think I will normally be welding above a current of 125 amps, which means normally not more than about 18 amps of supply current. I'm only using 2.5mm sticks, and they go up to 90 amps, more or less. So a 3.2 amp stick goes up to 130 amps, and that's probably the biggest I would need to use. I'm only fabricating little bits really. So perhaps the best way for me to go is the 16 amp connection. But don't take anything I say as absolute truth, because I'm not an electrician. You've got to decide for yourself. On the rarest occasions that I might ever weld at 160 amps, then even the 16 amp MCB Class B might stay in for 10 minutes, and I don't think I'll have runs of 10 minutes anyway. So I can see why Artec have specified a 16 amp connection. So I've covered getting the thing, putting the trolley together, and the first bit of welding. I'll build up my skills over the coming weeks. I'll try some TIG, but for now, if you're a novice like me at this, I hope it was useful to you. Thank you for watching. Hacks be shared.